All right, welcome. Today, we're diving into a critical mission in the world of algebra, isolating the absolute value. Seriously, this is the single most important first step for a whole class of equations, and by the end of this, you're going to have it down cold.
So you see something like this on a test. It can look a little intimidating, right? You've got multiplication, subtraction, and these weird, mysterious bars right in the middle of everything. The biggest question is, where do you even begin? Let's figure out that first move.
I want you to think about this like a rescue mission. See that X in there? It's trapped inside those absolute value bars. You can't just reach in and grab it. So what's your first move? Well, in any rescue, the first thing you do is clear the area around your target.
And that, right there, is our main goal today. Before you even think about the x plus 3 or whatever else is going on inside, your one and only mission is to get those absolute value bars completely by themselves on one side of the equal sign. Get them alone.
To do that, we have to follow the golden rule. And it's simple. Think of those bars less like a box and more like an impenetrable shield, like an energy field. You can move stuff around the shield, but you can't get through it. Well, not yet anyway.
So let's put the official name on it. This whole process is called isolating the absolute value. It's just the fancy way of saying our mission is to get that box, with everything inside it, totally by itself on one side of the equation.
This right here, this is your mantra. If you remember literally nothing else from this, remember this quote. You cannot touch the inside until the outside is clear. Say it with me. You cannot touch the inside until the outside is clear. It's the key.
Okay, theory's great, but let's get our hands dirty. It's time to look at the actual rescue tactics you're going to use. We're going to go step by step and see exactly how to clear the area around that shield. Our first tactic is the most basic one. So here we've got our absolute value, x minus 2, but there's a pesky plus 7 hanging around outside. Our variable is trapped, and that 7 is the first guard standing in our way. So what's the plan? We just use our basic algebra rules. What's the opposite of adding 7? Subtracting 7. So we subtract 7 from both sides to keep things balanced, and poof, the 7 is gone. The absolute value is now isolated. First step, mission accomplished. Okay, let's level up. In this problem, there's no addition. Instead, we have a -3 being multiplied by our absolute value. Now, this is a spot where a lot of people make a huge mistake, but our shield rule is going to protect us. Here's the crucial thing. You do not distribute that -3 inside the bars. Remember, the shield is up. You can't break through it. The opposite of multiplying by -3 is dividing by -3. We do that on both sides, and we get the absolute value all by itself. See? Easy as that. All right, time to combine our skills. This is the final challenge. Look at this. We've got two things outside the bars, a division by 3 and a subtraction of 4. This is going to be a two-step rescue mission. So which one do we handle first? Just think of your regular order of operations, but in reverse. We always deal with addition and subtraction first, so we add 4 to both sides. That's step 1. Now we deal with the division by multiplying both sides by 3. And there you have it. X plus 1 equals 15. Isolate it. We are ready for the next phase.
Now listen up, because every good mission briefing covers the dangers. There are 2 really common traps that people fall into all the time when doing this. Let's make sure you know exactly what they are so you can avoid them. Trap number 1 is by far the biggest one, illegal distribution. Oh, it is so tempting to just multiply that 2 into the x and the 5. But you can't. Remember the shield. It's a solid wall. You can't distribute through it. You have to get rid of that 2 by dividing first, period.
The second trap is just getting impatient. You stop the isolation process too early. You might see a problem like this and be tempted to jump right into figuring out what x is. But hold on. You absolutely must get rid of that plus 5 first. You have to finish the isolation mission completely before you can even think about what comes next.
So we've learned the tactics. We've learned how to avoid the traps. But you might still be wondering, why is this one step so important? Why does this single mission matter so much in algebra?
I love this analogy because it makes perfect sense. Think about it. The answer you want, the value of x, is like the pieces of a bookshelf you just bought. They're inside a big cardboard box. You can't possibly start building the bookshelf until you get rid of all the plastic wrap and cardboard, right? Well, isolating the absolute value is removing the packaging.
So just remember, isolating isn't just a suggestion. It's the required first step. If you skip it, you'll get the wrong answer. It's the one thing that prevents all those common mistakes and builds a solid foundation for every single absolute value problem you'll ever see again. Master this, and you're going to be in great shape.
So we've done it. We've successfully isolated the bars, we've cleared away all the packaging. The box is officially open. And that leaves us with one final, very interesting question. Now that we can finally look inside, what do we do next? Well, that's a story for our next mission.